We're going to start with division. I've done a lot of multiplications. We're going to start with division. When you divide terms or variables, you first divide coefficients. When dividing variables, you do as we have done with multiplication. You represent a single variable as a single variable, and then you subtract the denominator exponent from the numerator exponent. Please highlight these. Always write the expression in the simplest form. Remember to write the variables in alphabetical order. Unlike terms can be divided but cannot be added or subtracted. I did put this note in the previous videos and people kept on making the same mistake. You cannot add unlike terms. However, you can divide or multiply them. Here's one example. I've been asked to simplify that. Firstly, I'm going to start by dividing coefficients or integers first. What is 3 divided by minus 3? 3 divided by minus 3 is minus 1. However, when you divide variables, I said you're going to write it as a single variable. So here I'm dividing x squared with x squared. I'm going to write it as x, but I'm going to take the numerator exponent minus the denominator exponent. Same with y. When I divide y's, I'm going to write it as y, but it will be to the exponent of 5 minus 4. When I divide t, I'm going to have t, but it will be to the exponent of 3 minus 2. Now, this is what we're going to have. I'm going to write x squared divided by x squared. You just write it as x, but you take the numerator exponent, you minus the denominator exponent, which is 2 minus 2. Y exponent 5 divided by y exponent 4, you write it as y, but you take the numerator exponent, which is 5, and you minus the denominator exponent, which is 4. T exponent 3 divided by t exponent 2. So you will write it as t, but you will take the numerator exponent minus the denominator exponent, which is 3 minus 2. This negative 1, I said it is 3 divided by negative 3. 3 divided by negative 3 will just give you negative 1. You don't have to write it as a coefficient. You can just write it as negative. But we know that there is 1 there as a coefficient. 2 minus 2 will be 0, so x will be to the exponent of 0. 5 minus 4 is 1, so y will be to the exponent of 1, and t will be to the exponent of 1 because 3 minus 2 is 1. Divide integers first. When dividing variables, represent as a single variable and subtract their respective exponent. By subtracting the respective exponent, I simply mean that take the exponent of the numerator minus the exponent of the denominator. Later on, I'm going to show you a little bit of a twist to that, where the highest exponent is in the denominator. I will show you how to do that as well. Now, this is what you will have. What is x to the exponent of 0? everything to the exponent of 0 is 1. So x to the exponent of 0 will just be 1. So my answer here will just be yt, negative yt. Let's go to the next example. The next example is that. This is not what we have been doing so far. There's a problem with this because now we have two terms in the numerator. When we have two terms in the numerator, what are we going to do? You're going to give each denominator its own exponent. You're going to give each numerator its own denominator because they do have a common denominator. And the common denominator here is 5x squared. So I'm going to give 10x cubed its denominator, which is 5x squared. In between, I will still have this minus. And then I'm going to have 25x to the exponent 8 divided by 5 exponent 2. So both of your numerators will have that denominator, which is 5x squared. Then you can apply the rules that we did in the previous example. What is 10 divided by 5? It is 2. What is x cubed divided by x squared? X cubed divided by x squared. You will write it as x, but you're going to take 3 and minus 2. I still have minus. What is 25 divided by 5? It is 5. Then I'm going to divide x to the exponent 8 with x squared. I will simply represent it as a single variable, but I'm going to take 8 and minus 2. So this is my answer here. When two or more numerators share a denominator, split the fraction by giving each numerator the same denominator as they share it. Once you've done that, for me to get you, I said 10 divided by 5, it is 2. X cubed divided by x squared, you represent it as x, but you will take the numerator exponent minus the denominator exponent. Guys, please remember, whenever we're dealing with division, you minus the exponents. But when we deal with multiplication, you add the exponents. Multiplication means to expand. I think it's nice in Zulu because they say okwanda. It adds. So when you multiply, you add the exponents. When you divide, you subtract the exponents. In this case, when you divide variables, you will write it as a single variable, but you're going to take the exponent of the numerator minus the exponent of the denominator. 25 divided by 5 is 5. When you divide variables, you represent it as a single variable, but you're going to take the numerator exponent minus the denominator exponent, which is 8 minus 2. And this will be your solution. 3 minus 2 is 8 minus 2 is example 3. How many terms do we have in the numerator? 1, 2. Terms can only be separated by plus or minus. Later on you'll learn that they can also be separated by equal sign. Can I say 20 plus 30? I can't. Why? Because these are unlike terms. Here m is to the exponent 4, here m is exponent 5. Even though the variables are the same, the exponents of those variables are not the same. And here is to exponent 6, and there is to exponent 3. So how do I simplify this? You split the fraction. You give each numerator its own denominator as they share that denominator. 20m4 and 6 and 30m5 and 3 share the denominator, the same denominator, which is 10. So give this its own denominator, which is 10mn, and give that its own denominator, which is 10mn. In between, we still have that plus. Now you can apply the rules. What is 20 divided by 10? 20 divided by 10 is 2. And m to the exponent 4 divided by m to the exponent 1. It'll give me m to the exponent of 4 minus 1, which is m cubed. And 6 divided by n1. N exponent 6 divided by n exponent 1 will give me n, but I'm going to take 6 minus 1, which is 5. I still have plus. 30 divided by 10 is 3. M exponent 5 divided by m exponent 1. I will write it as m, but I'm going to take 5 minus 1, which is 4. N exponent 3 divided by n exponent 1. It is n, but I'm going to take 3 minus 1. Four minus 1 is 3. 6 minus 1 is 5. 5 minus 1 is 4. 3 minus 1 is 2. Divide integers first. When dividing variables, represent as a single variable and subtract their respective exponent. Let's do this example here. Before you can divide, you realize that in the numerator you've got 2 terms, but in between you've got multiplication. In the denominator you've got 2 terms, but in between you've got multiplication. You start first by multiplying. So I'm just going to say minus 12 multiplied by 14. And a exponent 3 multiplied by a exponent 1. B exponent 2 multiplied by B exponent 2. This is what you will get. Minus 12 multiplied by 14 is 168. A cubed times A exponent 1 will be A 3 plus 1. B squared times B squared will be B 2 plus 2. Minus 21 times minus 8 will give you positive 168. A squared, there's no a there, it'll still be a squared. B exponent 1 times B exponent 5 will be B 1 plus 5. There it is. Simplify that. This is what you're going to have. 3 plus 1 is 4. 2 plus 2 is 4. We still have a squared. 1 plus 5 is 6. 168 and 168, when you divide them, they will give you negative 1. Now you're dividing. A exponent 4 divided by A exponent 2. You will write it as A, but you will take B exponent 4 divided by B exponent 6. This is where I said I'm going to give you guys an example of how to do this later. This negative 168 divided by positive 168 will just give you negative 1. Here we have B exponent 4 and we have B exponent 6. B will go to where it has the highest exponent. In this case, the highest exponent of B is in the denominator. So my B will still be in the denominator. But now I'm going to take the denominator exponent, which is 6, and minus the numerator exponent, which is 4. And that will be your solution. You could have done it this way, but I don't want you guys to do it this way. Please do it the way I did it previously. This is your homework. Guys, please check. When I say exercise 9 and 10 book A, you don't do activities that I've already done as examples. Now I will tell you which ones to do. I will send a message to the group.